My name is Amanda Glosson, and I've been pushing pixels around screens for over 10 years now. Mostly what I mean when I say that is I've been writing software for a while. But I've also worked on my fair share of design projects along the way. Recently, I found my way into pixel art, which is actually how I ended up here in front of all of you today, talking about thinking inside the box. Thinking inside the box. What box am I talking about? What's in the box? Oh, should I go back? Okay. The box I'm talking about is one that is bounded by constraints. Constraints are just defined as limitations or restrictions imposed on your project. And the space inside that is our problem space. That's the bit where we get to work and solve a bunch of problems. In the case of my pixel art, my constraints are very straightforward. Pixels can either be filled or transparent. My canvas is 8 pixels wide by 16 pixels tall. And recently I've started to limit myself to the NES palette. So I have a very nice and neat looking 128 pixel canvas for my problem space. This isn't an awful lot to work with. When I first started out, nearly every sprite I drew felt impossible at first. How am I going to draw a drum set? This is not the right form factor. It's not even going to fit. Tires are round. They are not rectangular. Dinosaurs are really, really big. I usually only work on pixel art during my train commute, and as time went on, I began to notice that I was drawing faster. Instead of only drawing one a day, starting it on the way to work and finishing it up on the way home, I was making 2 a day. Then I made 3 a day. And then I was making 4. And I was finding that I was more quickly finding creative solutions inside of my problem space, and I started to suspect that my familiarity with my constraint set was helping me get better at this. But I wasn't really sure because there aren't a lot of people out there who are like, yeah, constrain yourself. Dream really small, right? No one says that, ever. So as soon as I started considering these constraints, I was immediately reminded of a presentation I attended at this year's California Extreme about the arcade game Defender. So this is an arcade game that was developed in 1981. That was a long time ago. It's a 2D side-scroller where the player flies the starship around this alien terrain, and you're trying to protect these astronauts from some aliens. The talk at California Extreme was given by 2 of Defender's developers, Eugene Jarvis and Sam Dicker. And they were there to talk about the constraints that they faced and their design process when working on the game. When they started development, they had never designed a video game, and they didn't know anything about hardware, so they were like, well, let's get the best CPU available. Now again, this is 1981, so what they got was a 1 megahertz Motorola 8609 with an 8-bit processor. It had some 16-bit operations. They had 12 kilobytes of ROM, 48 kilobytes of DRAM, single frame buffer, and 16 colors. This was actually pretty good at the time, but they were still really constrained by their hardware, and these constraints informed the design throughout the development of the game. So, for example, Eugene Jarvis chose to set the game in space because he thought the abstract setting would help to obscure their simple graphics. The landscape see at the bottom, is only a pixel wide, and that's mostly because the hardware wasn't powerful enough to generate anything more detailed. Again, instead of creating assets in the game, Sam Dicker wrote some particle effects to generate unique explosions. So that was pretty cool, powerful software at the time. Because these hardware limitations caused their graphics to be somewhat simplistic, they had to focus on their gameplay to make a good game. No one was going to look at this and be like, oh wow, incredible. Even though they did have 16 colors, which was kind of a big deal at the time. So they created a bunch of characters and projectiles, and each sort of had its own personality. The personality emerged from some simple rules-based AI that they developed. And when they were on the screen together, you ended up with a sort of notoriously punishing ecosystem. So this team of guys with limited hardware knowledge, developed a game which, since its release, has become one of the highest grossing arcade games ever. So they get to the end of this talk and I'm like, whoa, these guys are wizards. Like, do people even write software like this anymore? Like, I'm at work complaining that I have to support IE7. Like, I have incredible resource. To be honest, at first, I sort of dismissed this story as even being about the constraints. I sort of attributed their successes to be more based on their programming genius. So I kept digging for other examples. So I started thinking about Weird Al. So to create his parodies, he reuses the existing melody, rhythm, intonation, and rhyme scheme of the original song and uses new subject matter to illustrate a completely different message. These are pretty intense constraints when you talk about a song that's nearly everything. So in the case of Eat It, he removed one letter of Michael Jackson's Beat It to transition a song about walking away from violence into being one that mocks the idea that eating food keeps it from being wasted. So his entire career has been exploring this framework of musical constraints, and certainly he's created own original content, but he's most known for his parodies. So okay, maybe Weird Al is also a genius. He's a musical genius. So I kept looking. So in 1960, it's 54 years ago, Bennett Cerf bet Theo Geisel $50 that he wouldn't be able to write an entertaining children's book with only 50 unique words. You might know Theo Geisel better by a pseudonym of Dr. Seuss. Dr. Seuss won that bet with his story Green Eggs and Ham. Since the publication of Green Eggs and Ham, it sold more than 200 million copies, which makes it the most popular of his works, and it's one of the best-selling children's books in history. So here's a list of the 50 words that were used. That's all of them. You too can go home and make Green Eggs and Ham. So at this point, I now know that Defender, Eat It, Green Eggs and Ham were all created under heavy constraints. And I think, okay, so there's clearly some relationship between constraints and ideas. We've already defined constraints as being limits or restrictions, so let's also define what an idea is. For the sake of this exploration, I want to define an idea as being a connection between two pieces of knowledge that you have in your brain. So you have piece of knowledge A, piece of knowledge B, and the link between them is an idea AB. If we follow along with this pretty simplistic definition of an idea, then looking for ideas is really reduced to being a search problem. That's pretty cool. So we know how to do that. Let's write some pseudocode. So for every node in your knowledge, compare it to every other node. Let's make a link. And just for completeness, let's make sure it's not the same one. and we have idea AB. So the efficiency of the search is defined by the set of knowledge that we're talking about. And if you're interested in big O notation, you already know what the complexity of this is, but I put it on a slide so you can take a look at it. So by using this simple definition of an idea, we're able to see that perhaps adding constraints to limit the set of knowledge that you have to search over for ideas could be of a benefit, simply from an efficiency standpoint. So we certainly don't want all of the ideas. And we shouldn't be satisfied with just having relevant ideas. What we really want are the good ideas. Actually, scratch that. We want the creative ideas. So what's a creative idea? A creative idea is a new idea that is also useful, generative, or influential. Useful meaning it's a new idea that solves some sort of problem. Generative meaning it's a new idea that leads to other ideas. So if you think about our loop before, maybe you make AB and you throw it back in your set of knowledge and it gets very messy and complicated. Or it's influential, meaning it's a new idea that changes the way people think. So how do we choose our constraints? How do we do this in such a way that we are able to narrow down our search to be able to find these creative ideas? From our previous examples, you might think, oh gosh, maybe we should just add a bunch of random constraints and see what happens. But that's actually probably not what you want to do. So let's take a look at a paint by number. This is a paint by number hamburger. The problem space of a paint by number is totally filled with constraints, 100%. The starting place is the burger with a bunch of numbers in it. I fill in spaces labeled 1 with the paint that's labeled 1. And I do the same for 2. And I do this until all of the areas fill. So if you and I both do the same paint by number and we follow the rules, because we're rule followers, our pieces would come out looking the same. A coloring book page is only a slight step up. There's still not an awful lot of room for creativity here, especially because this is a horse skeleton. There are constraints that do not promote creativity, but instead promote conformity. So we need to ensure that our problem space is actually not well defined. There needs to be some room for the unknown, and we also want to choose these constraints strategically. If chosen correctly, a constraint can push you towards the goal that's paired with it. For example, you want to promote the expansion of your lexicon. Write poetry where every syllable is going to count. You have to pick the right words. You want to promote cross-browser compatibility? Don't use browser prefixes. Don't use bleeding edge features. Or maybe only use IE8. Promote contrast. You can maybe only use black and white for your slides. So there's also more common constraints that we're going to find that we're not going to be able to do a lot about. For example, we need to make our clients happy. We needed to have it done yesterday. Regardless of what sets of constraints you end up stacking up, they're going to create a problem space for you to move around in. And it's probably not going to look as nice and neat as this. It's going to be more messy. It's going to look maybe more like this. Your constraints are going to overlap. You're going to create some weird spaces, a weird framework for you to work inside of. Maybe after a while, that space becomes something that you fully grok, a space that you can quickly move around in because you know where all of the boundaries and barriers are, and a space where you start making your way into the smaller nooks. When you get wedged up into one of those, you're going to be coming up with ideas that are generative. You're going to be looping them back in your for loop that we talked about earlier. You're going to be creating new ideas with them. You're going to be informative. Other folks that you work with are going to pick up your ideas, and it's going to change their mind, and they're going to have new ideas with those. And ultimately, these ideas are going to be useful. You're going to be solving problems with them. You're going to be churning on creative ideas. Maybe you begin to identify common constraint frameworks in your work, and they become familiar and supportive as old friends. Even if you don't become best friends with your constraints, I hope that you'll take away some of these ideas to help you identify, appreciate, and use your constraints to your advantage in discovering creative solutions in the projects that you're working on. You can feel free to find me on Twitter if you want to talk about constraints, but just be sure to keep it under 140 characters.